In this video, we're going to look at solving radical equations. So these are equations that have those square root, cube root, etc., different radical terms in them, but they're equations, not expressions, so we'll have an equal sign. So you've probably already been doing this without thinking about it as radical equations, because anytime you're solving, something squared, you're using a square root, or if you're undoing a square root and you're squaring, you're using those same skills we are about to use as we go through this. So here we have a big messy equation, and I want you to remember those order of operations before we start getting to that x in there. So for example, if I told you that x was 5 and then you started to solve this using order of operations, the first thing you would do is 5 minus 1, then you would take the square root, then you would multiply it by 5, and then you would add 3, and you would get to your answer. So as we're trying to go backwards, we have to undo those order of operations, and we need to be careful the way we do it. We can't right now square this and only cancel the square root. It would be a much more complex thing if we squared each side of this equation just right off the bat. Let's try to get this square root section all by itself, and then we can square to undo it. So going backwards through those steps, I said the last thing we would have done is add 3, so I'm going to subtract 3 from both sides of this equation. And I've got 5 times our radical term. I'm going to get rid of that times 5 and divide by 5 on both sides of my equation. And now I'm down to just that radical term on one side. Now, if I square, it will cancel this square root without doing anything extra crazy, because it is just canceling that outermost operation. Notice how, I can't add 1 to get rid of the minus 1 right now. It's stuck under the square root. I'm going in backwards order to undo these steps. So undoing square and square root, now we've got just x minus 1. This guy's 49, and we would add 1 to both sides and end up with x equals 50. Now don't forget, if you're ever not confident in your answer, you can just take that x value, plug it right back into the original equation, and make sure it comes out to what we wanted. All right, now this might look really different to you off the bat. You don't see a radical term, but don't forget those fractional exponents do have those roots in there. So this is really x to the 4th, and then we're taking the cube root of it, right? And I can undo either of these exponents first. It doesn't really matter. I can undo the to the 4th, or I can undo the 3rd root. But for me, I would rather do the thing that looks easiest first. For example, if I was undoing the cube root first, I have to cube 81, which is going to be some huge crazy number. So I don't want to undo that right now. I think I'm going to undo the to the 4th power. So I'm going to actually take everything to the 1/4 power, or I'm going to undo that to the 4th. So we're going to do the 4th root of 81. Now I know the square root of 81 is 9, and I know the square root of that is 3. So that's how I can get my 4th root of 81. I can square root twice. But you can also put that in your calculator. So this side is 3. My to the 4th and my to the 1/4 cancel out, and I just have x to the 1/3 power right now. Or remember, that could be written as the cube root of x. So if I want to undo that, I'm going to cube everything, take it to the 3rd power. X is just x now, and 3 to the 3rd power is 27. That means if I went back to my calculator and I put 27 to the 4/3 power into my calculator, that should equal 81. So you might look at this and say, Lindsay, there's no radical term in this. How are we solving a radical equation? Well, my question for you is, can we factor this quadratic? Are there 2 numbers that multiply to 31 and also add up to negative 12? Hopefully you're saying, no, Lindsay, of course not, out loud to your computer. So we have to use the quadratic formula. And when we do that, we will end up with a radical term. So let's go. Quadratic formula, x is going to be equal to negative b plus or minus the square root of b squared minus 4 times a times c, whole things over 2a. So plugging in our values, x is equal to 12 plus or minus negative 12 squared is 144 minus 4 times 1 times 31. Whole thing's over 2a, so 2 times 1. We've got 12 plus or minus the square root of 144 minus 124 over 2. So that radical in there is 20 over 2. And then let's just simplify that a little bit. Square root of 20, what could we rewrite that as? I could rewrite that as the square root of 4 times the square root of 5. And I do in fact know what the square root of 4 is. So this becomes 12 plus or minus 2 root 5 over 2. And now I can cancel a 2 out of each of those terms. 6 plus or minus root 5. And since the bottom is just 1, I can put it in, but I don't have to. My two answers here are 6 plus root 5 and 6 minus root 5. All right, here, when we try to solve this for x, you can turn this into general form for a quadratic and solve it that way. But we can also use the square root property. So if I add 18 to both sides, now I've got 3x squared equals 18. I can divide by 3, and I've got x squared equals 6. And now I can just take the square root of both sides, right? And don't forget, you're going to have two solutions, positive root 6 and negative root 6. That's an irrational number, not much else I can do with it. So when I have this binomial term being squared, nothing on the outside being multiplied, divided, added, subtracted to it, the most outer operation happening is squared, I can just square root both of these sides. Be careful though, because the square root of 36 could be 6 or it could be negative 6. So we're going to set up two versions of our answers here. And then we'll solve each of these for x. So x could be 1, but x could also be negative 11. Those are our two solutions. All right, when we have radicals on both sides, again, we can square both sides and get rid of those, but be careful, we're squaring the entire left side of the equation and the entire right side of the equation. So 2 is getting squared as well. We have 4 times x, and over here, the squared and the square root cancel each other. We've got x minus 3. This guy we can just solve for x. We've got 3x equals negative 3, and when we divide, we should have x equals negative 1. Okay, same idea here, it's just getting a little bit more complicated. Square the whole left side and the whole right side, and we've got 9 times all of that. I'm putting it in parentheses now because it was a term under the square root sign, so we got to make sure that we multiply 9 with everything in there. Over here we've got 8x plus 12. So multiplying that 9 out, we've got this big old guy. Let's see, I'm going to move this 8x over. Get 19x. It's 12. Add that 45 on both sides. We end up with 19x equals 57. And gosh, if we divide by 19, I think that's going to be a nice number, weirdly enough. I think that's going to be 20 times 3 would be 60. I think 19 times 3 is going to be 57. And x equals 3. All right, if I were to square the left side and square the right side, notice I would have a mess because I would have to FOIL 3x minus 5 plus 5 with root 3x minus 5 plus 5, and that is going to be a bigger mess than we really want it to be. I don't want to have that. It's going to be way too much work. Instead, let's isolate that square root term first, and then we can square both sides without having to FOIL a bunch of nonsense. Now we can square both sides of the equation, and we're going to have square and square root cancel. We have 3x minus 5 on this side and 49 on the other. Adding 5 to both sides, we're at 54 and 3x. And when we divide that, we're at 18. Okay, same idea here. Use caution. We're going to move this plus 2 away from the radical term so that we can square this side of the equation without getting a bunch of extra radical terms. But when we square the right side, we have to FOIL. So this is turning into just 3x plus 16 because the square and the square root cancel out. But this one is becoming, I'm going to put my little foiling over here, x plus 2 times x plus 2, x squared plus 2x, that's an x, plus another 2x plus 4. So this is going to become x squared plus 4x plus 4. Now that there's an x squared term in this equation, we have a quadratic. And how are we going to solve a quadratic? We need to get it completely equal to 0 on one side, and then we can use maybe factoring, maybe the quadratic formula to try to solve for x. So let's move this 3x and this 16 to the other side. See what we've got. 0 equals x squared plus x minus 12. So you can always use the quadratic formula, but just because we don't have to, let's see, are there two numbers that multiply to negative 12 but add up to positive 1? And there are. X plus 4 and x minus 3 should multiply out to get me back to negative 12. So those are going to be how I get my two solutions. X plus 4 equals 0 and x minus 3 equals 0. So x could be either negative 4 or 3.